I am Anusri Manaj and today I am going to present my seminar on topic knowledge representation. When we want to talk about knowledge representation, we must talk about computer vision. Computer vision is a field of artificial intelligence that enables computers and systems to derive meaningful information from digital images, videos, and other visual inputs and take action or make recommendation based on the information. If AI enables computers to think, computer vision enables them to see, observe, and understand. Computer vision works much the same as human vision, except humans have a head start. Human sight has the advantages of lifetime of context to train how to tell object apart, how far away they are, whether they are moving, and whether there is something wrong in an image. Here we go, our main topic knowledge representation. Knowledge representation refers to the process of capturing and organizing knowledge in a way that allows a computer or an intelligent system to understand, reason about, and manipulate that knowledge. Knowledge representation in computer vision refers to the methods and techniques used to represent and organize visual information for understanding and reasoning about the visual world. Here is go our types of knowledge. There are mainly five types of knowledge: declarative, that is declarative knowledge, procedural knowledge, heuristic knowledge, structural knowledge, meta knowledge. First, we go on declarative knowledge. Declarative knowledge is to know about something. It includes concepts, facts, and objects. Second one is procedural knowledge. Procedural knowledge is a type of knowledge which is responsible for knowing how to do something. It can be directly applied to any task. Third one is heuristic knowledge. Heuristic knowledge is representing knowledge of some experts in a field or subject. Fourth one is structural knowledge. Structural knowledge is basic knowledge to problem solving. It describes the relationship that exists between concepts or objects. Fifth one is meta knowledge. Knowledge about the other types of knowledge is called meta knowledge. Here is the main four techniques of knowledge representation, that is logical representation, semantic representation, production rules, frames representation. Here we go our first technique of knowledge representation, that is logical representation. Logical representation is a language with some concrete rules which deals with the proposition and has no ambiguity in representation. Logical representation means drawing a conclusion based on various conditions. This representation lays down some important communication rules. It consists of precisely defined syntax and each semantics which supports the sound inference. Each sentence can be translated into logics using syntax and semantics. Here is our second technique, that is semantic network representation. Semantic networks are alternative of predicate logic for knowledge representation. In semantic networks, we can represent our knowledge in the form of graphical network. This network consists of nodes representing object and arcs which describes the relationship between those objects. Semantic networks can categorize the objects in different forms and can also link those objects. Semantic networks are easy to understand and can be easily extended. This representation consists of mainly two types of relations, that is ISA relation. It indicates inheritance, and second one is kind of relation. Here is our third technique of knowledge representation, that is frame representation. A frame is a record-like structure which consists of a collection of attributes and its values to describe an entity in the world. Frames are the AI data structure which divides knowledge into substructures by representing stereotype situations. It consists of a collection of slots and slots values. These slots may be of any types and size. Slots have names and values which are called facets. Facets are various aspects of a slot. Facets are features of frames which enable us to put constraint on the frames. The fourth technique of knowledge representation is production rules. Production rules represent knowledge as a set of ifs and rules. Each rule consists of a condition, if part, and an action part, then part. Action part known as then part. Production rules capture knowledge in the form of conditional statements and provide a way to perform rule-based reasoning. They are widely used in expert systems and rule-based systems for decision making and problem solving. Knowledge representation in computer vision. Knowledge representation in computer vision refers to the methods and techniques used to represent and organize visual information for understanding and reasoning about the visual world. Computer vision systems aim to extract meaningful information from images or video sequence, and knowledge representation plays a crucial role in capturing and utilizing this information effectively. Here, there are several common approaches to knowledge representation in computer vision. Here is the main 5 approaches: feature-based representation, symbolic representation, graph-based representation, deep neural network representations, semantic embedding representations. Feature-based representation. First one is feature-based representation. In this approach, visual features such as edges, corners, textures, or color histogram are extracted from images. These features serves a low-level representation of visual information and can be used for various tasks such as object recognition, image matching, or segmentation. The second approach is symbolic representation. Symbolic representations use high-level symbols or concepts to represent visual information. These symbols can be objects, scenes, relationships, or actions. Symbolic representation allows for reasoning and inference using logical or semantic rules. For example, an object recognition system might represent a car as a symbol and reason about its properties and relationship with other objects. The third approach is graph-based representation. In graph-based representation, model the visual world as a set of nodes connected by edges, where nodes represent object or image region and edges represent relationship or interactions between them. Graphs can capture both local and global visual context, enabling reasoning about complex scenes. Graph-based representation have been applied to tasks such as object detection, image segmentation, and scene understanding or segmentation. The fourth one is deep neural network representation. Deep neural networks representation is based on deep learning. With the rise of deep learning, convolutional neural network, that is CNNs, have become a dominant approach for feature extraction and representation learning in computer science and computer vision. Convolutional neural networks automatically learn hierarchical representation from raw image data, capturing both low-level visual features and high-level semantic concepts. These learning representation can be used for various tasks such as image classification, object detection, and image recognition. The fifth approach is semantic embedding representation. Semantic embedding represent visual information as points or vectors in a high-dimensional semantic space where distance or similarities between points reflect semantic relationships. These embeddings are typically learned using techniques like metric learning or generative adversarial networks, that is GANs. Semantic embedding enables tasks like image retrieval, zero-shot learning, and image synthesis. Here we go conclusion. In conclusion, the seminar on knowledge representation in computer vision has shed light on the fundamental role it plays in understanding and reasoning about visual information. The seminar explored various techniques and approaches used to represent and organize knowledge in the context of computer vision. Thank you.